All right, this question is course schedule. So in this question, they give us a catalog of courses, and our goal is to take all the courses. And they come with restrictions. For example, to take course B, you need to first take course A. So there's two main ways to go about solving this. The first way is we want to detect a bad catalog of courses. So what does a bad catalog of courses look like? It means that there's something infeasible. So to take course A, you need to have first taken course B. To take course B, you need to have first taken course C. But to take course C, you need to have first taken course A. And you can see here that in this cycle, there's no way for us to actually start taking a course. So this is a bad catalog. And this is really just detecting a cycle. So each one of these arrows here is a prerequisite, right? So in this question, this would be expressed as, I believe, B, C. So to take course 0, you have to first take course 1, which is expressed as 0, 1. So that means to take course B, you need to first take course C. So B, C. Okay, so that's one way to go about it. The other way is we will kind of just simulate taking all the courses. Simulate like going through and taking courses. Simulating taking courses. And this is actually, as we'll find out later on, just a modified topological sort. Now in this video, I'm going to go over this solution because I feel like it keeps the theme of the question, like we're actually going to try and take these courses and see if we can actually graduate with this catalog of courses. Okay, so how do we go about with simulating taking courses? So what we want to do is we want to express our courses and our prerequisites as a graph. So for example, here we have, to take course C, you need to first take course A. To take course D, you first take course C. So that's how you read this graph. And as an aside, if you're able to have a directed graph where you can have all your arrows pointing in a single direction, this is called a topological ordering. Okay, so here's how we'll simulate taking our courses. So first, we'll have to represent this somehow. So how we'll represent this is we will have A, B, C, D, E, F, and they will tell us, what courses do you need to have taken in order to take that course. Here's our prereqs. So course A has no prerequisites. There's nothing that course A needs to take in order for you to take it. So let's have available to take list here. So we can take course A. Okay, so what else can we take here? So B has no prerequisites, so B is also available for taking. For here, we have C. And you can see here, in order to take C, you need to have first taken A. So this has one prerequisite. Okay, so then what else do we have here? We have D. And D, in order to take D, you need to first take C. So D also has one prerequisite. E doesn't have any prerequisite, so we can take it right away. So these are zeros. And F, you can see that there's actually two prerequisites that you need to finish before you can take F. Okay, so now we know that we're allowed to take course A, B, and E. So let's just go ahead and try taking them. So let's take course A. So when we take course A, we find that we actually clear a prerequisite for course C, right? So this gets deleted. We finish course A, so now we're, you can see here, course C from 1 goes down to 0. We finish a prerequisite. So when it hits 0, that means this is now an available course that we can take. So we have C here. And next, we look at the next course that we're allowed to take, which is B. So we'll take B. B is not a prerequisite to anything. Maybe it's an elective. So that's the end of the story for B. And next, we will look at E. And E, you can see here, when we take it, we actually finish a prerequisite for F. So F here goes from 2 into 1. Okay, so we have that. And now we look at C, and you can see here C is a prerequisite for D and for F. So when we take C, we actually cross out this line and this line. So for D, this becomes 0. So this is an available course to take now, so we'll mark it. And then the same thing also happens for F. And now that's also an available course, and we'll add it. Okay, so C is done. We take D, D doesn't go anywhere, and we take F. And you can see here, the number of available courses that we ended up taking was equal to the total number of courses. So the total num courses that was offered in this catalog. Therefore, this is a good catalog. You can take every single course in it. So that's how we will simulate taking all our courses. Okay, so now we just need to figure out how to represent this, how to represent this, and also how to represent our graph. Okay, so our graph with these edges, what we'll do is we'll turn this, we will turn this into, let me just copy it here. Much like the previous video, if you've watched it, we'll turn this into basically here's A, B, C, D, E, and you can see here A points to C, B has nothing, C goes to D, and also to F, D goes to nothing, and E points to F. So here's all the red arrows that I crossed out. So this will just be here, this will just be an array list. And here will just be an index into an array of array lists. So we'll have an array list of an array. So for example here, if I do array list at C, this would give me the array list DF. Okay, so now that we have all the pieces in place, let's try and code this out. So first, let's create our graph. So let's call it our catalog. So we'll have an array list of integer, and this will be an array of our catalog. And it will have the same size as the number of courses that we're taking. Okay, so now we want to actually fill up our catalog with the prerequisites. So for int prereq in prerequisites, what we want to do is AB means that to take A, you need to take B first. In other words, if, so we'll have int A equals prereq at 0 and int B equals prereq at 1. That means we want this catalog for this B, we want to add the edge A. So that means, we have a B pointing towards an A. So remember that BC means that there is an edge going from C pointing towards B. Now the other thing that we need to keep track of here is the number of prerequisites for each course. So what I'll do here is, because we're already using prereq, I'll turn this into an edge instead. And then we'll have our prereqs, so also num courses. And now we know that the prereqs for A has increased by 1. There's one prerequisite we need to take before we need to take A. So this is number of courses you need to take before you can take prereq at I. Okay, so now we have our prereqs, we have our catalog with our prerequisites for how to follow them. Now we need to find out what our available courses are. So what are our available courses to take? So this you can represent with any kind of list data structure out there. You can use a stack, you can use a queue. I'll use an array deck for this scenario. So this will be our available courses. So this is our available courses. Okay, so let's fill up our availables. So for int I equals 0, I less than num courses, I plus plus. And what we want to do is if prereqs at I equals 0, so there's no prerequisites, then available add last, we will add this as a course that's available to take. So no prereqs, we can take this course. Okay, so now we want to simulate taking courses. So while available.size is, or I guess you can just go available is not empty, then what we want to do is we will take this course. So int course is going to be equal to available.remove front. So we'll take our first course. So when we take a course, we can decrement the number of courses that we need to take. And then at the end, we can just return that num courses equals 0. So we've taken all available courses there are. Okay, so after we take a course, we've unlocked some of the prerequisites here, right? So what we want to do here is for int other course, so for int, I guess, the next course that you can take in our catalog for this course. So this tells us the prereqs that this course satisfies. What we'll do is prereqs at this next will be minus minus. So we've finished a prereq. And if prereqs at next happens to be 0, so we finish all the prerequisites for this next course, then available.add last next. So add this course to our available courses to take. Okay, and I think that's pretty much it. So try running this. Remove front is not available, so this should be remove first. All right, so if this works out, we'll go over the runtime. Oh, no pointer. Let's see. On line 11. Oh, right. Okay, so here, because we're doing array list, we can't just blindly call add. We have to initialize it. So if catalog at b is equal to null, then catalog at b is equal to new array list. Similarly for here, we can't just assume that this will point to an array list. So if catalog at course does not equal to null, so there's actually, this course actually fulfills prerequisites for another course, then we'll perform all of this. All right, one more try. Cool. Now we'll submit and hopefully go over the runtime. Nice. Okay, so let's go over the runtime and space complexity here. So runtime and space. Okay, so with space, you can see we're already doing an array with num courses. So there's already O of n right there. And then we do another one, but it's also the same size. So it's still O of n there. We have an array deck here with available. Now you can never have more than the total number of courses available to take. So this is space-wise also bounded by O of n. So we basically have 3 O of n's here. So this is O of n. Good to go. Okay, now for the runtime. So first we went through all the prerequisites. So this is basically of all of the edges. And let's see here. And then we are going to go through this every single course here again. So this gives us a runtime of O of n, where n is the number of courses, because we try and find the first set of available courses to take. So already this is O of e plus n. And let's look at this simulate taking courses. Now, when we're simulating taking courses, we will at most look through every course if they're available to take. And then within each course, we look at their edges. Now, we never look at an edge twice, and there's only, there's only this many edges, right? So this is O of n plus e again. So we look through every node. If there's if every node is available to take. And for each node, we look through its edges, and that's basically the same as the total number of edges in this graph, or it's limited by that. So the runtime will still remain at O of e plus n. Okay, that's the end of this question. If you want me to go over the cycle solution instead, I'm happy to do that. Just leave me a comment. Okay,